not a lot of new stuff, you know, today. It's just kind of a little, we got to make things difficult on you. A little slant on how it's going to be worded today, but a lot of finding the angles, like where it says inverse sine, inverse cosine, inverse tangent. You know that. That is that second tan, second cos, second sine on your graphing calculator. We use that to find angle measurements. So it's just going to be written a little bit differently. Solving for angles, that's what we're going to work on. And of course, we're going to have, you know, a little Pythagorean theorem, a little SOHCAHTOA, all the good stuff. Okay, so good review here. Thinking about our final exam too. Recall that for a function to have an inverse, it must be a one-to-one function. There, we haven't talked about that for a while. Now, that's why I put this on for you. To be a one-to-one function, you have to pass the horizontal line test. So vertical line test if it's just a function, a plain old boring function. Horizontal test, one-to-one. Has to be one-to-one in order to have an inverse that exists. Now, this is something that comes up in later, the next chapter, actually, after we get back from winter break. We got to talk about these graphs, because this is where we're working on in trig pre-calc right now with these crazy curves. So like the sine curve and then the cosine curve. Those, of course, go on forever. This would clearly not pass the horizontal line test. Neither would this guy, okay? So that is where we're going to have to do some restrictions on where we draw the triangles, which quadrants we draw the triangles in. So that's what we're really leading up to. So we have to restrict their domains. So that's what we're taking a look at. So for our sine function, of course, so notice they're restricting you to this. So then you're going to have your answers in the interval from -1 to 1. So exactly once, so it does make it a one-to-one function. Now this all seems like craziness to me. So wordy. And it says I'm going to make your life easy on the next slide here. This can be done, of course, for cosine and tangent. So you're probably already questioning, like, where the heck are we going to be drawing these? And that's what all of this boils down to. So sine, cos, tan functions on those restricted domains are going to be one-to-one. They would pass the horizontal line test with these following ranges. So it's the ranges I'm really looking at, the outputs, where I can draw these triangles at, and that's going to tell you the quadrants. Now, first, this does not mean sine to the -1 power. Remember, that is the inverse notation for that. So sine inverse, it says you can draw between -90 and +90 radians. We're in radians here. So if I'm thinking on my graph grid between -90, +90, that's on that right-hand side. So you can draw it in quadrants 1 or 4. Cos inverse, I'm thinking about on between 0 and pi, or between 0 and 180. So that's your top two quadrants, 1 and 2. And then tan inverse, you're back to your -90, +90, so you're 1 and 4. Now, you're probably looking at this and you're like, holy cow, so I got to keep track of all students take calculus. Now I got to keep track of where I can draw these inverses. I'm like, here's the thing. 98%, if I had to throw a number at it, 98% of them are going to be in 1. Okay, because it does get dicey trying to keep track of where to draw everything. I'm going to draw some in some of the other ones, and you'll see that in a minute. But majority of them are in 1. So when in doubt, you can kind of fall back on that. Now, other thing too, and this is just vocab, sometimes, and it's kind of a 50-50 split that I've seen it in the different books. Sometimes we just use our inverse notation. Same thing, arc sine, arc cosine, arc tan also mean inverse. All just fancy ways to say inverse functions, okay? Brooklyn, glad you made it. Okay, so like I said, this is why I pointed out that last page of last night's homework, because we're taking a look at really talking about finding the angles. You know sine of pi over 6, 30 degrees, is opposite hypotenuse 1 over 2. So the other way to kind of spin that around is sine inverse of a half, because we're after the angle, is of course the pi over 6. So we're asking you for the angles today. I can't stress enough that it's the angle. Have I said angle enough today? I thought I'd say it one more time. One more time. So the next example, the first example, is nothing different really, a whole lot different from that last page of your homework. You're finding the angle, one angle, not two this time, one angle, and we have to be conscientious of which quadrant we are drawing it in. Okay, so sine inverse. So I'm asking what angle has a sine √3/2. And of course I got to think about where I'm drawing it. Now I know √3/2, I'm already thinking 30, 60, 90 obviously. Sine inverse you can be in 1 or 4. And how I'm going to determine whether I'm in 1 or 4 is whether my fraction's positive or negative. Well, clearly it's positive, so I'm going to draw it in 1. If it was negative, I would have drawn it, of course, down in 4. Okay, sine we know. For the thrill of knowledge, our missing side is 1. Most important, what is the angle across from the side that measures √3? 60. And they want these to be given in radians. You know what's 60 degrees in radians? Pi over 3. So this is a whole lot, nothing different from that last page of your homework. We just have specific restrictions on where you're drawing it. So we pass our horizontal line test and have an inverse. All right, cosine, I gave you -1/2 on purpose. Just for funzo. Now, remember your restrictions on cosine. Cosine can be in 1 and 2. Which quadrant are you going to draw it in? 2, because of it being negative. And of course, we know cosine, adjacent, hypotenuse, thrill of knowledge, √3. And you already told me across from √3, 60. Now, final answer though, of course, obviously not 60, that would be in quadrant 1. We have to measure from 0 around. You're 60 short of 180, 120, which is what in radians? 2 pi over 3. Quick on the fractions. I like it, Owen. Mister, I'm not studying for the final. Yeah.
There's a reason.
Oh my gosh.
There's a reason. Oh. Holy enchilada. Choices. Okay. All right. Tan inverse can be in, of course, 1 and 4. +1. I'm looking at that +1. So I'm going to draw this in quadrant.
What?
I like the enthusiasm. Tangent, of course, opposite over adjacent. So I'm just thinking fraction style, of course. Now, you were on which, I got fancy this time, not really. You're on which special triangle this time? 45, 45, 90.
Thank you.
There we go. All right, Owen. What is 45 in radians? Look at how quick you are. So proud, so quick, so proud, so quick. Okay, any questions on that? So again, nothing really new, just a little different slant on it. Now, okay, calculators. Some of you, I don't know whose water bottle that is. Some of you are going to be very, very mad when I give you your quiz back from yesterday, because some of you only missed one problem. You had one problem wrong, -1, because you had your calculator in the wrong mode for one of the calculator problems. And I'm like, oh man. Okay, find the approximate solutions for the given expressions. Are we in degrees or radians? Radians, all those angles, all the angles for inverses are radians. So you magically have to know you better be in radians. When you're doing inverses, they want the angles in radians.
Are you kidding?
So, I'm in radians. Make sure, what are we rounding to? Does it say? No, it doesn't say. All right, so second sine, 0.71.
Yeah, you can study this on?
No. Ooh. All right, what are we running? It doesn't say. What are we going to round to? 0.789? How does that work? Okay, tan inverse of 2, type it in. This is nothing magical here. Second tan 2. Can we just round everything to 3 since I did the first one? 1.107.
Yeah, I know.
All right, cos inverse, type that one in, second cos of
Yeah,
2.
my calculator would be wrong.
Okay, so now I got a little nasty message. My calculator's mad at me. Why is it mad at me?
I don't know.
Oh, and I thought you knew everything.
Oh, and I thought you knew everything. Oh,
It's not in the range. The domain, it's over the domain, it's not 1.
It's everything what Avery said is correct. And plus I'm thinking to myself, well, how could you draw yourself a triangle to get an exact angle if I could? How could I make a triangle where the adjacent's bigger than the hypotenuse?
You can't.
Is that going to be proportionate on your triangle geometry, mathematicians? Sure isn't.
Yeah, oh, you need another 100 units.
Ooh. Okay. All right. Let's do the last one. What's your last one? Do I need to type it in?
It's 0.
Okay. Cos inverse. I don't know why, but sometimes, like when kids get 0, that weirds them. Or cos inverse of 1. I can't type here. Second cos of 1. There we go. Okay. All right. So nothing too wild or crazy there. Any questions on this? Your mode has to be in what? Radius. Now, I know I'm being super dramatic about the mode situation because, like I said, some of you only missed one thing on the quiz because your calculator is in the wrong mode. And you're going to see the more different styles of problems we do, it's going to switch around. The problems, some will be in degrees, some in radians, etc. It is super important you're being really conscientious on your mode on your calculator. There's no reason to get that wrong, okay? Okay, so solving for angles and triangles, of course, we know how to do this. We've done sides, we've done a lot of Pythagorean theorem, a lot of SOHCAHTOA. Now we're going to get angles. So first question for you. Which trig ratio, sine, cos, or tan, are we going to use to find that angle theta? Well, you got opposite hypotenuse. I like it. Opposite hypotenuse. Now, I know 10 over 50 can reduce. You can reduce it if you want. Next question. Does it anywhere in the problem indicate radians versus degrees?
No.
So technically I really wouldn't care, but usually, and it's easier to give your answer in degrees. So when I see we've got some word problems coming at us, so I would probably want those in degrees. So I'm going to be conscientious on my mode.
Oh my gosh. This is, I'm going to fail.
You're not going to fail.
Yes, you guys are going to fail.
You're not going to fail. Second sign, I can't bring myself to type in 10 over 50. I'm just going to use, what's 10 over 50 reduced to? Yeah, I can't type 10 over 50. That bothers me. Okay, so let's round it. Let's say, I don't know, 11.5. Give or take. So again, it didn't specify degrees or radians on a quiz. If you gave me the radians version, I wouldn't care. A lot of times, this is kind of my general rule of thumb, give the answers in degrees unless I specifically say I want it in radians. Inverse is implied to be in radians, though. When you have the inverses, that's a default to radians. Okay. Oh, look, I don't have to draw a picture. Aren't you happy about that? Nobody wants to see me draw anything. 40-foot ladder. It's the ladder. Lays against the building. Base of the ladder, 6 feet from it. What's the angle formed by the ladder in the building? So you're finding this little tiny angle theta. What trig ratio are you using? Sine. Because we have the opposite side, 6, and you know the hypotenuse, of course, 40. And of course, you can reduce that if you want. You punch it in, you get a small angle.
8.6.
I like it, 8.6. If you rounded it to 9, I don't care. Anybody need me to type that in? I love this stuff. Okay, another lovely picture because nobody wants to see any more of my drawing skills. That ship has set sail. Lighthouse is located on an island 2 miles from the straight shoreline. I feel like being a weight up here. Express the angle formed by the beam of light and the shoreline in terms of the distance d in the figure. Man, that's wordy. So here's the thing. We're not actually going to be solving for anything per se because you don't know the measurement of both sides. We're going to be getting an algebraic expression. First question, theta. What trig ratio am I using, sine, cos, or tan?
Just kidding, tangent.
How about tan? Tan, opposite adjacent. It's okay. It's Friday, late in the day. Opposite adjacent.
That's close.
Now, here's the thing. We got to read these directions again. Blah, blah, blah. Express the angle. So I want this theta equals. How would you calculate theta? So if you did have a number, let's say you knew the D was, I don't know, 12. You would hit what in your calculator?
The negative.
Tangent inverse, tangent inverse. So you would do tan inverse
Stop. Oh,
a 2 over D. If we actually knew what D was. They just want you to give an expression for theta. I can't actually solve for it because I don't know what D is. Just for the record. Love it. Any questions on the word problems? All right, let's talk modes. Here we go. Find all angles between 0 degrees, etc., that satisfy the equation. What mode should your calculator be in? Degrees. Okay. So type them in. Sine inverse. We want the angle, so you're doing your sine inverse of 0.4. I rounded to the 10th. Round to whatever, I guess.
23.6.
Got it. And I know you're like, I can't believe she's making us do more of these calculator problems. But again, you're going to be so mad if this is the only thing you miss on a quiz or a test. Okay, to do this one, of course, cos inverse of 0.4. And I don't care, obviously, in a test or whatever, if you write cos inverse of 0.4, you just put the answer. What do you got for this guy?
64. Nope, just kidding. 66.4.
Like that. I like the positivity. Okay, any questions on the calculator? And you will even see from now on, like on the day of our test, which is, by the way, next Friday, and when we get to the final exam, you know I love to put all my lovely directions on the smartboard. You will see, like, there'll be a big one on there that says, watch your calculator mode.
How many questions are on final exam?
67 multiple choice questions. 100 minutes to do 67 multiple choice.
Wait, that we don't have any, like, open. That means I have like A through D.
This is probably, I'm gonna, okay, let's finish it up. So these are, oh boy. All right, here we go, people. Final 2. Let's get it done. Now, these look a little crazy, the wording, but I promise you they're easy. You just got to figure out what they're asking you. Expressions like cosine inverse arise in calculus. Quiet, paying attention. We can find exact values, no rounded off decimals, of these expressions using identities, right triangles, all that sort of stuff. So first thing, I'm looking at this and I'm like, this looks like a foreign language up here. So I'm thinking, where am I going to start? Order of operations, parentheses first. So I'm zeroed in on that right now. Well, sine inverse, I know it can be in 1 or 4. I see it's positive 3/5, so I'm going to draw where? 1. And remember, 98% of the time I feel like they're in 1. So don't be like, why is it so much in 1? Don't doubt it, you're right. And of course, sine opposite hypotenuse. For the thrill of knowledge, we should know the third side. It's a Pythagorean triple. If you didn't know it, you would use Pythagorean theorem, obviously, but that would be sad. Now, final answer. Final answer. I want the cosine of that triangle. What sides represent cosine?
Adjacent and hypotenuse.
So 4 over 5, final answer, we're done.
Yes.
So it looks crazy, but it's very simple. What's in parentheses you use to make the triangle, and then you identify the sides of the trig ratio on the outside. So let's do a couple others. Okay, write sine of cos inverse of x and tan of cos inverse of x. And okay, all right. I'm just going to kind of. So again, I'm working on the first expression, parentheses first. Cos inverse can be in which quadrants?
1. I mean, yeah. Wait, 1 and 2.
Where are you drawing?
1.
1, because x, I know it's weird that it's x, but x is positive x, I'm going to draw on 1. Now, x, I think x is fraction form, cosine inverse. So you have adjacent over hypotenuse. So I'm going to label adjacent x, hypotenuse 1. Final answer I want, we're going to do a little work here. I need the sine. So I'm like, okay, I know what sine is. Sine's opposite over hypotenuse. We all know that. But I'm like, oh crud, I don't have the opposite side. So I'm going to have to do a little bit of work here on Pythagorean theorem because it's going to have a variable in it. So I don't want to call this side x because this is x and I think that's going to be really confusing. I'm going to go old school Pythagorean theorem. I'm going to call it a because I'm thinking a squared, b squared, c squared. So I'm going to do a squared, x squared, c squared. We all know 1 squared, so I'm just going to leave that. Solving for a, I'm going to subtract x squared over, and then I'm going to root it. Bless you. Now, I know plus or minus in front of that, of course. I'm thinking about my plus or minus. Due to your location, you're going right and up. You're going to use the positive. So I'm just going to label this as positive. I'm not putting the plus, but positive. And now I'm like, I got it. Opposite is that lovely square root. And of course, hypotenuse is 1. My final answer, I probably wouldn't leave the over 1 part, but I'm going to leave it on right now for dramatic emphasis. I don't care if you have more. We're not done. We got one more expression to evaluate. But I've got the picture. We already drew the picture. I want the sides for tangent. All right, well, tangent, big whoop. Opposite adjacent. I'm all over it. Opposites are crazy square root. Adjacent, x. There's my second answer. Now, other thing too, just one other comment on these. You could, depending on what trig ratio I had you find, have that square root in the denominator. Why is that gross? Because I'm like, oh God, we have to rationalize it, and that's a whole lot of, whoa. You do not. If you have something like this where you have that in the denominator, the radical, you do not have to worry about rationalizing it. You can just give me the sides. I really only get nitpicky about the rationalizing if you have a numerical value. Like if you have square root of 5 in the bottom, I expect you to rationalize it. Hey, for fun, so let me grab your homework here for you.